Hello and welcome back to the channel. The topic for today is unlocking the secret of React hooks. So what are React hooks? React hooks were introduced in React 16.8. They allow developers to use state, context and other React functions in functional components instead of class components. Hooks are functions that allow you to hook into React's internal state and lifecycle features. This provides an alternative method for creating React components while also simplifying the overall React codebase. Developers can use hooks to create reusable modular code that is easier to understand, test, and maintain. Previously, developers could only add state and lifecycle methods to class components. Overall, React hooks are a game-changing addition to React framework that has drastically improved the way developers write React code. Now let's discuss how React hooks work under the hood. React hooks enable developers to use state and other React features without use of class components within functional components. Hooks are JavaScript function that provides a way to manage state and perform side effects within functional components such as UseState and UseEffect. When a hook-enabled component is rendered, React creates an internal object to store the state and connects it to the component. React updates the internal state object and re-renders the component when the state is updated via the hook. UseEffect hooks are executed after each render and can be used to perform side effects such as data retrieval or DOM manipulation. To encapsulate logic that can be reused across multiple components, custom hooks can be created. Overall, React hooks enable developers to write more modular and maintainable code by allowing them to use React features in functional components in a powerful and flexible manner. Now, let's talk about UseState and UseEffect hooks in React. The UseState and UseEffect functions are the most commonly used React hooks. The UseState function allows developers to manage state within functional components, whereas the UseEffect function allows them to perform side effects within functional components. The UseState function accepts a starting value and returns an array containing the current value as well as function to update the state. React will re-render the component and update the UI when the state is updated using the function returned by UseState. The UseEffect function takes an argument, a callback function, and executes it after each render. This enables developers to perform side effects such as data fetching or DOM manipulation without causing unnecessary renders. The UseEffect function allows developers to specify dependency and control when the UseEffect runs. Developers can easily manage state and performance side effects within functional components by using UseState and UseEffect functions, eliminating the need for class component. Now let's talk about creating reusable logic with custom hooks in React. Custom hooks are JavaScript functions that enable developers to extract component logic and store it in reusable functions. They allow you to share common functionality across multiple components without having to duplicate code. Custom hooks are capable of encapsulating any stateful or side-effecting logic that can be reused across components. They are implemented as regular JavaScript functions that make use of either built-in React hooks or custom hooks. Custom hooks should be named with the word use to indicate that they are hooks and can be used in functional components. When a component uses custom hooks, it receives hooks defined state and behavior, allowing developers to write more modular and maintainable code. Developers can create abstraction that can easily be used and reused across multiple components by creating custom hooks. Custom hooks are an effective way to create reusable logic in React while also improving the overall structure of the code. Next, we can discuss the rules of hooks in React. The hooks rules are the set of guidelines to follow when using React hooks in functional components. The goal of these rules is to ensure hooks are used correctly and that the component's behavior is predictable. Hooks according to the hooks rules can only be called at the top level of a function, component, or custom hook. Hooks should not be called inside loops, conditions, or nested functions because this could lead to unexpected behavior. Hooks must be rendered in the same order so that the React can track them properly. Custom hooks must also adhere the hook rules, which states that they can only be used with other hooks and cannot have any other side effects. By following the hooks rules, developer can make sure that their React components are reliable, predictable, and maintainable. Understanding and adhering to these rules is essential when using React hooks in order to prevent potential bugs and guarantee that your code base is properly organized. Let me summarize for you. Developers can use state, context, and other React features in functional components without the use of class components thanks to the React hooks, an important addition to the React framework. The UseState and the UseEffect functions, which let developers control state and side effects in functional components, are two most frequently used hooks. Use custom hooks to separate the usable logic from components and distribute it among various areas in your application. When using React hooks, it's crucial to adhere to the rule of hooks to make sure that your components are correctly structured and behave predictably. Overall, React hooks make it easier to write reusable and maintainable code and offer a simpler, more flexible way to build React components. Developers can write functional components that are simpler to test, reason about, and refactor by using hooks. React hooks are a very useful tool for creating cutting-edge, scalable web application and representing an exciting evolution in the React framework.